In this short series, we're going to learn about unsupervised learning. We talked about supervised learning already, where we try to predict something from data. Another big task in machine learning is unsupervised learning. The primary difference in unsupervised learning with respect to supervised learning is that unsupervised learning does not include any data labels. You're doing the learning without having ground truth labels. Why would we want to do this? Well, let's look at a few examples. In this first example, let's imagine that we have grades from students in a course, and the students have all taken a particular exam, and we plot their exam scores on a one-dimensional line like we see below. So in this case, we see that there's a lot of grades all over the map, but kind of ranging from the low 60s all the way up to almost 100. But there's not too many scores in the 90s. So if we were to assign letter grades based on the traditional scale of 90s are A's, 80s are B's, 70s are C's, then a lot of students wouldn't make A's. Most students would not make an A. But that might not be fair because maybe the exam was hard. Now, if you've ever taken a college course, you know that for college exams, they always give a bell curve. In other words, another way they might do it is clustering the grades to assign letter grades. For example, we could say that all students who fall in the highest cluster of grades get an A+. My face down here, so A+. The next cluster get an A, the next cluster get an A-, next cluster get a B+, and these clusters are irrespective of like any number that they get. It's based on how close together and where the different groups of grades are. So that's one example use case of unsupervised learning, where we're trying to learn the groups or clusters. Another example of clustering might be in a recommender system where you're trying to group listeners together and provide them with similar music content. Let's say Spotify might do this. And for example, and this is a very simplified example, but we can imagine that Spotify might collect data on the proportions of songs that you listen to that are pop rock and plot that proportion on the X1 axis, as well as the proportion of songs that are pop rap that you listen to, and that's the X2 axis, and then plot each person along this X1, X2 axis, or this pop rock, pop rap axis. And then to find groups of listeners with similar music taste, apply some clustering algorithm to find the groups. And then this circle here might be given a similar group of songs. This circle down here might be given a similar group of songs, etc. So that's another use case where we might use unsupervised learning. You could imagine that this idea of clustering data together could be used in many different use cases, and therefore unsupervised learning is used a lot in the real world. Not as much as supervised learning, but it is still used. In the next video, we'll go into some details of a very popular unsupervised learning algorithm.